Let's start with the 17th question of exercise 10.3. The triangle ABC with vertices A 2 comma 3, B 4 comma minus 1, and C 1 comma 2. Find the equation and the length of altitude from the vertex A. So here the triangle is given ABC with their vertices. We have to find the equation of this altitude from vertex A. So the given vertices of triangle ABCR A 2 comma 3 B 4 comma minus 1 and C 1 comma 2. Let D be the point on line BC where line AD is perpendicular to line BC. That is AD line segment is altitude from A. So as you can see that AD is perpendicular to BC, and I can find the slope of BC. Slope of BC is y2 minus y1 upon x2 minus x1. So this 2 minus minus 1 upon 1 minus 4, 3 by minus 3 minus 1. The slope of AD will be reciprocal and additive, that is what. Also AD passes through point A using point slope form equation of AD will be y minus y1 is equal to m into x minus x1. Y minus 3 is equal to 1 into x minus 2. X minus y plus 1 equal to 0 is the equation of altitude. They have also asked that is the length of altitude. Now as you can see that this point A is outside the line and exactly perpendicular to it. So I can apply the perpendicular distance of the point 2 comma 3 from the line BC. We don't know the equation of BC. So first of all, we will find the equation of BC. So equation of BC is y minus y1 upon y2 minus y1 is equal to x minus x1 upon x2 minus x1. This is 2-point form. And we know that the line BC passes through 4 comma minus 1 and on 1 comma 2. So we will apply 2-point form to find the equation of line BC. So y minus 1 upon 2 minus minus 1 is equal to x minus 4 upon 1 minus 4. This is 3 whereas this is minus 3. So 3 ones are 3 minus 1. So y plus 1 into minus 1 is equal to x minus 4. Minus y minus 1 is equal to x minus 4. So x plus y minus 3 equal to 0 is the equation of line BC. The perpendicular distance of the point 2 comma 3 from the line x plus y minus 3 equal to 0 is we know that formula p is equal to mod ax1 plus by1 plus c upon root of a square plus b square. So in place of x I will give the x coordinate, in place of y I will give the y coordinate minus 3 upon square root of coefficient of x is also 1, 1 square 1, coefficient of y is also 1, 1 square 1. So this 3 will get cancelled out and I am left with 2 by root 2, which is ultimately root 2. So the length of perpendicular, that is the length of altitude is root 2, whereas the equation of altitude is x minus y plus 1 is equal to 0. Let's start with the 18th question. If P is the length of perpendicular from the origin to the line whose intercepts on the x-axis are A and B, then show that 1 by P square is equal to 1 by A square plus 1 by P square. Right. So the length of perpendicular from origin to the line whose x-intercept and y-intercept are A and B respectively is P. So equation of line in intercept form is x by A plus y by B is equal to 1. Therefore x by A plus y by B minus 1 equal to 0. See if I can draw this on figure, then this is my origin O. The perpendicular from this to the line x by A plus y by B minus 1 equal to 0 is given P. So applying perpendicular distance formula, P is equal to mod ax1 plus by1 plus c upon square root of a square plus b square. So in place of x, I will keep this x coordinate, that is 0 by a plus 0 by b minus 1 upon square root of coefficient of x whole square plus coefficient of y. This is your p. Therefore, p is equal to, this will be just minus 1, but as it is mod, I will take 1. 1 by a square plus 1 by b square. Squaring will give me p square is equal to 1 by 1 upon a square plus 1 by b square. So cross multiplying will give me 1 by a square plus 1 by b square into p square is equal to 1. Therefore 1 by a square plus 1 by b square is equal to 1 by b square. This is your required proof. Right. Chapter 11, conic section. See, as the name suggests, conic section. Section is just cutting the planes, right? You might have studied in physics also. Studying sections means cutting any figure and then just studying the shape that was obtained. Here you can see that we will section the cone, and that's why here the name is conic section. So first of all, though, we will obtain the cone. So what I will do is I will take two lines. What is my axis? This is my axis. This is my vertical line, and I will take one more line, which is called as generator, which will make some angle with axis, right? So we'll require two lines to form a cone. One is my axis, which will be fixed, and generally it will be a vertical line, but you can take any line. But remember that axis will be fixed, and generator will revolve around this axis, making some angle with the axis. So you can imagine that if I rotate this generator about this fixed point V or the vertex, then the figure obtained will be like this, two cones. Right, with this as V and this as my axis. So this is how we obtain a cone. using axis and generator. Axis will be fixed, it will stay on its place only, and generator will revolve around the axis, making some angle with the axis, and will observe the uh, figure obtained. So this type of figure we will see when this generator will revolve very fast around this axis with respect to this point V. This is called upper nap and this is called lower nap. Now if I take some one plane and section this cones at different angles, and if I study the shapes obtained by doing sections of this cone, will give me the uh, different shapes, uh, that is will have circle, ellipse, parabola and hyperbola. Let's try to just section this cone by taking this plane exactly perpendicular to this axis. So if I just section this cone with my plane exactly perpendicular to the axis, and if I study the section obtained, then it will be a perfect square. Uh, Sorry, not a square, perfect circle. The figure obtained will be perfect circle. So the first figure obtained is circle, but the condition is that I have to take this plane perpendicular to axis. Now if I increase this angle, and this is my axis and these two lines are the generator and this is my vertex. Now if I increase my angle with the axis, then if you observe the section obtained over here, will not be a perfect circle, but it will be somewhat oblong circle, which in mathematics we call this shape as ellipse. So you can see that we are doing the sections of cone, and we are getting different shapes. That's why the shapes obtained are called the conic sections, as the shapes are obtained doing the section of cone, right? See, if you want to just see this very clearly, then it is given in your textbook on page 238. Very clearly they have shown using figures that if I go on increasing my angle of this plane with the axis, then I will have different shapes obtained. As you can see that first was the circle. When I take my plane exactly perpendicular to axis. If I increase my angle, we'll have oblonged circle, which is also called ellipse. If I keep on increasing my angle, so that this plane just come out of this net, then the figure obtained will be parabola. Let's try to visualize this uh, in figure. The figure will not be that much exact. If you want the reference, then you can just open your textbook and observe it on page number 238. So this is my cones with axis and generator, and this is the vertex where these two cones meet each other, right? This is called upper map and this is called lower map. Now if I further increase my angle and cut this section of cone, then you will observe some shape like this on the cut section. This will go down to this fill generator. So this type of shape will be observed. If I draw this clearly, then it will be this type of shape will be obtained, which is called as parabola, right? And if I still increase my angle and make it exactly parallel to my axis, that is this plane, so you will observe two type of parabolas. One will be over here in upper, and one will be somewhat down over here. So this shape obtained is called hyperbola. So you can see that by doing the section of cone at a different angles, we obtain four different figures. First was the circle, then again increasing my angle gave me ellipse, then again increasing the angle will give me that will give me parabola, and again lastly taking my plane exactly parallel to the axis will give me hyperbola. So we got four figures or shapes, and we will study about them in the following section. We got circle, ellipse, parabola, and hyperbola. So in the following chapter, we will study each of these figures, equation related to these figures, and all the basic terms